In this situation, there are a couple of key things to recognize from the problem. First of all, we're on a horizontal surface, and there's an applied force that is horizontal. There is an acceleration, so that means we do not have any equilibriums horizontally, and we're given a coefficient of friction and a mass of the object. Now, recognizing the contact forces and the field forces, we want to draw a free body diagram. So, first force we have is the 200 Newton force that is applied horizontally. Then we can recognize that we have a force of the weight, field force, contact force of the normal force of the object being supported, and then also a frictional force being applied. Always list out the given, that mass of 40 kilograms, and that coefficient of friction of 0.27. Now, headed into part B, we want to calculate the value of the frictional force. Our friction formula, mu times the normal. We know our mu value, but what we need to calculate is our normal force value. So, let's sum the forces in the y direction. Vertically, we only have two forces, the normal force and the weight. And remember, weight is equal to mass times gravity. So that tells us our normal force value is going to be equal to that 40 kilograms multiplied by 9.8. We can fill that in then for the normal force. Multiply it by the coefficient, and that'll give us our value for our frictional force. Now, part C, we want to calculate the acceleration of the crate. The crate's going to accelerate horizontally, so we want to sum all the forces in the horizontal direction. We've got an applied force of 200 newtons, and then a frictional force of 105.84 newtons opposing that. That's equal to mass times acceleration. Do the algebra and solve down for the acceleration. Remember, when you write your acceleration, always state the direction to the right. Ponder physics.